Hello, dear students. Today we have another request from one of my daughters, so one of my dear students there, really. She sent to me on WhatsApp about this uh, chapter, College Panda, second edition, chapter 7, constructing models, example 2. She need to know more about what happening here in this example. So we have to eliminate the explanation here, try to explain the model here. Okay. Um, he mentioned in this uh, example, he mentioned water was pumped into a tank at a constant rate until it was full. And we have full stop here. So we have respect to time, we have a volume of water or capacity, just amount. He didn't mention what happened. So we have water increased like this. Each time water increased until become full. Full up to when, we don't know. Full to here, to here. He mentioned in all problem should be full here, you see? Same level. So we assume that it full here. Time passed and volume of water, amount of water increased according first phrase. Then the tank was then drained, so will be leaked. No water still the same amount will be leaked, but at what? At slower. What does it mean? This is time, right? So we have time here up to here, whatever. Put any number up to you, or just take it as a distance here. You see, this is the distance is the time till it fall. If will be slower, so from here we can make it to graph. You see, we can make it to graph like this. We have what? We have falling or full tank here. Then slower. That means this is say 10, say 10 hour, maybe to be full. Okay, this is assuming. Set it to be full. Take 10 or less or more. Slower. You see, slower. So should be take more time to drain. Sorry, to be empty, to be drained until he mentions that the tank was then drained at a slower rate than it had been filled. So will be empty, take longer than 10. So if the same amount here 10 is here 10, say as an example here is 20, maybe I will extend the line here. So if we mentioned about the timeline, 10 and 10 here as well, same amount, you see, this is 10. So we have here at 20, 10 and 10, till here 10. Length here is 10 and length here is 10. If we make it at the same rate should be like this, because will be full and empty at the same rate, like isosceles triangle. But it will be slower. So slower take longer time, more than 10. This is the timeline here. You see the timeline here more than 10. 10 is this length. Is it clear? So should be according the graph. Okay, this is our problem here. Sure, it's D, but let us discuss the foregraph here. Okay, why is D? Between the answer should be between A and C and D. You see what I'm doing? I just divide the graph each one into two period time. So we have this time here, the time length in this one is bigger. To be full, time pass, amount of water increased, be full at this point, time is bigger here. Here, when it rained and to be empty, the time is small, is faster. To be empty, faster, very fast. You see, it's about the save time. If this takes 30 hours, takes 10 hours or something like this, 30 minutes, 10 minutes. Very, very a difference here. Very big difference, you see? So the difference between both is clear. So to be full, very slow, to be empty. This is opposite what he gives us here. In this one, to be full, take a short time, a very small length or very small period, and to be empty when it drain and leak, take longer time. So slow means take long time or longer time. Is it clear? Why A is very wrong, cannot consider Y at any way. Don't think about Y, because Y start at time zero, already amount exists, not bounded. Just he put amount at once at the beginning of the system at time zero, we put amount of water. Then after while, we don't know which time exactly, up to you. Say here is 10 minutes or 10 hours. After 10 minutes or 10 hours here, he just take about more than half of amount of water. Why half? Because this is the distance more than this. Take it one time, like we put it in one time. We tank it in one time. Just take it in one time, amount, and still fix it for a very, very long time. Here, still fix it for 10 minutes. The amount still fixed or about whatever the time here. So this not considering at all. This why wrong? Because it's at zero time already full, yes, full up to zero. This time here become full, and still falling, increasing the amount. So maybe not leak, but it's capacity increase in the tank. The tank, the tank is stick at a specific level. Say we hear the tank of water should be covered this level to be full, because the other one for pressure or something like this to cover it or something like this. So it is still full, maybe make explode or bomb it or whatever. So not accepted here to be water is here, not accepted, still full. But the speed here, you see the speed of water, the rate of water, slope, the angle is very acute, means near to 100, near to 90, and the angle here is acute angle is a very small, not very acute, near to be horizontal, so it's slow here. In another way, okay, this is wrong. In another thinking, we think about the slow or the fast. Which one is fast? Which one is slow? The angle always with horizontal from positive or negative direction. This is from positive direction. This is angle, or we can make it in positive like this. Okay, positive direction here. This is for grade 12, by the way. Grade 12 this point, but this one for grade 10 and grade 11 already about the time here. We measure the time, but here in grade 12, we can make it very easy because this is a very big one. This is very small one. We study, actually compare the acute one. Compare what? The acute one, not the obtuse one. Even the acute one is the opposite way. You see, here, this is a small and this is big acute. Bigger acute is faster here. Here is faster because the slope is bigger, so it's faster. This is for grade 12, okay? another lesson about the slope or the gradients, how we detect the rate by gradients on the graph. In this part here, it seems the acute angle is smaller than here. So this is slope. So the amount fall at slower than be empty faster. On the other side here, this is our slope angle, and this is our slope angle. But when we compare acute angle, even the acute angle in the opposite way. So which one is bigger? This is bigger here. So the rate here, the slope, the gradient here is bigger. If the gradient is bigger, so it's faster. The rate is bigger as well. By the way, one of the definition of the slope is the rate. Is the rate increase between y-axis to x-axis. This is one of slope definitions. Okay, slope has a many definitions, by the way. So the rate is a slope, and also in this part, this angle is lesser or smaller than this one. So the angle is smaller. We don't talk about negative or positive. We take absolute absolute slope, because already negative means, by the way, negative means what? Drained or be empty. Decrease, positive increase. This is another explanation for grade 12. If you understand this, okay, not care about this one. If you are grade 11 or 10, take care about this explanation. Grade 12, this is very fast for you. Okay, so number D, in many ways, to be full is bigger, so faster. To be empty here or drained here is slower. Is slower than the other one. So this one, according this phrase, to be empty or drained, slower rate, and to be full is fast. Okay, so answer is D. I hope it's clear now, dear. If not clear, please PM me again on WhatsApp, or I can explain you in Arabic by voice note there. See you next question. Bye for now.